All right, I thought I'd post a video here with how to graph a couple of these different trig functions. Okay, so if we look at these two, feel free to have a look at both of them, okay, right now and try them if you like. I am going to do them one at a time, obviously. I don't even know if you guys can see this, can you? Is it too not bright? Is it too bright here? There we go. Is that a bit better? Okay, so anyways. If you look at this, y equals a bracket, right, sine b, x minus c plus d, we can see that my a value is my amplitude. Hopefully you can see that's 2, right? My b value, and that's 2 pi, or my period, sorry, my period that I need to use, right, my period that I need to use for my graph is 2 pi over b. So in this case, it's 2 pi over 4, okay, pi over 4, which means that it's 8. I don't care how you figure that out, just figure it out. Okay, divided by a fraction, so flipping time. So 2 pi times 4 over pi, right? Pi is canceled, 2 times 4 is 8. So that's your period. Now you have your phase shift of c, so it goes left 3, and this is your vertical displacement, so it goes up 1. I like to do the up 1 first right away. Boom, because here we go. That's my middle line. Right, that's kind of like the x-axis, so this is sort of a reference point, right? Now I can see my amplitude is 2, so it goes up to here and it goes down to here. That gives you your parameters, okay? Your graph now starts from there to there. So what are we going to do here? 1, 2, oh, not the best graph necessarily here. Hold on. Let me put the x-axis or the y-axis right here, okay? I'm going to change the y-axis. I'm going to put it there, and I'm going up to there, down to there. Gives me a bit of leeway, because I actually have to shift it left 3. So in order to go left 3, I'm going to go like this. Boom, there it is. So this is kind of where it starts now. Okay, so we have to figure out a couple things here. Now my period is 8. So what you want to do is you break your period up into 8 pieces so that you can graph it properly, right? So we'll just use these ticks as they are. So this is -3, -2. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, right? 1, 2, 3, 4, 5, 6, 7, 8. We'll make it pretty simple here. So what we have to understand is that this is the middle line. It's sorry, let me change that to cos so we don't get confused. It doesn't really matter. They're interchangeable, right? So cos, we know, starts at the top. So if this is a starting point, it starts up here, right? Okay, and it ends at 8. Oh, no, it ends at 5. My period is 8, so -3 to 5. It ends here. Right? So putting these dots in, understanding the period, you're going to end up in the same place. Now, remember the quadrant thing, right? So cos starts at the top, middle, bottom, middle, top, middle, bottom, middle, top, middle, bottom, middle, top. Well, top, your period is 8, so a quarter of 8 is 2. So after 2, you're in the middle. After 2, you're at the bottom. After 2, you're in the middle. After 2, you're at the top. After 2, you're in the middle. After 2, you're at the bottom. After 2, you're in the middle. After 2, you're at the top. Boom, and you're done, right? So now all it needs is connecting those dots, and you've basically got your cos function, all right? Now, here's a funky question. If I wanted to call this a sine function, okay? I wanted it to be a sine function. Well, if you started here, you could call it a negative sine because it goes down. So you could be y is equal to, still has the same amplitude, but now I'm going to call it a -2 because it's going down instead of up. Normally sine goes up. It's still got the same period, and it's gone to the left 1. So it's x plus 1, and it's still shifted up 1. Boom, there is an equivalent equation for that one there, right? If I wanted to call it a plus sign, I wanted the same amplitude, but now I want a +2 instead of a -2. Well, then you look at the graph. Where does it start in the middle and go up? It looks like it's right here. It starts in the middle and goes up, right? So what we're looking at is a +2, right? Still sine function, still got the same period, but now it's shifted to the right 3. So it's x -3, and the vertical displacement remains the same. I could keep going with this and call it a positive or a negative cos function here if I wanted, right? If you want it to be a negative cos function, it'd be -2x, -2, sorry, cos. The period is still pi over 4. Now it's gone to the right 1, so it's x -1 plus 1. Now, which one of these is the best answer? Well, which one is the simplest answer? If you wanted sine, I would choose the positive sine, and I would choose the positive cos. If I can avoid negatives, I do so at all costs. All right. So that, ladies and gentlemen, is graphing one of these functions. Now let's have a look at another. Okay. Negative 3 halves sine 2x minus pi over 3. So what we want to do here is probably rearrange this, take the 2 out, right? And then what are you going to end up with? You're going to end up with pi over 6 minus 1. Okay, so that's got a horizontal phase shift of pi over 6. You can see that it's gone down 1, so we're going to put our reference line, our middle line, 1 down. Let's identify everything first. It's going to have an amplitude of 3 halves. My b value is 2 pi over 2, which is pi, right? 2 pi over your my period, right, is 2 pi over b. So 2 pi over 2 is pi, so it happens every pi. It goes right pi over 6, and it goes down 1. So I've already done that. And now amplitude is 3.5. Well, let's make these a halves. Okay, so let's make that 1, let's make that 2, let's make that -1, -2. The beauty with constructing your own graphs is you have the liberty to break the x and y axis into anything that you want, right? 3 halves, and I've broken it into halves, which means it's going to go up to 1, and it's going to go, sorry, that means I should move this down. Oh, my apologies. Hold on a sec. If I go down 1, that means I go down to here. Okay. If I go up 3 halves, these are all halves, so I'm going to go up to 0.5, which would be my max function. And then I go down 3 halves to -2.5, which would be my minimum. So the range would be between -2.5 and 0.5, right? All right. So now, your period is pi. Okay, and you're going to be shifting it pi over 6. So this is where it gets a little funky, not too funky, but if you want to do the proper phase shift, it's probably a good idea to break it down into what your phase shift is in. And it looks like it's in 6, so it's 1, 2, 3, 4, 5, 6. Let's call this pi. Let's do a couple, 2, 3, 4, 5, 6. Let's do a couple periods. If I have a period in pi, if I do 2 pi, I'll have 2 periods, right? So that means that each one of these is pi over 6. 2 pi over 6, 3 pi over 6, which is pi over 2. This will be 3 pi over 2. And now let's sort of figure it out, all right? So we've broken up our axes. We found the maximum. We found the minimum. We found the middle. We've got the right, what do you want to call them? Right scale on the y-axis, x-axis to help us with the phase shift. I've now done that. I've got the period. So right pi over 6. So sine, negative sine, normally starts here and goes down. Well, I'm going to go right pi over 6, and I'm going to go down, okay? So if this is where I start, this is where I end, and this is where I end again. Okay, now a quarter, so 6, you break down to 1.5. So halfway would be 3. I'm going to end up in the middle again. Halfway into 3, I'm going to end up in the middle again. So down, middle, where am I? Oh, sorry, I'm on the x-axis here. I got to be on my thing. So I start here, my apologies, and I end up crossing here, and then here, and then here, and then here, right? So this is my middle. Negative means I go down, so a quarter of the way is 1.5, boom, there. Half, another quarter, I'm at the middle, right? Another quarter, I'm at the top. Another quarter, I'm at the middle. Another quarter, I'm at the bottom. Another quarter in the middle. Another quarter at the top. Another quarter in the middle. Once you've got all those points, ladies and gentlemen, it's pretty easy to connect them. All you got to do is this. Please do not make them like this. All right? These are curves. So you need to have them nice and round, okay? There you go. A couple different graphs, a couple different sketches, a couple different scales on the y-axis. This is in radians. This was just in numbers. Sometimes you have them in degrees. You're going to have to learn to break the scales up, the axes, into values that make your job easier. We will have plenty of practice doing these, folks. Please try the ones in the books, see if you can make it work, and have an awesome weekend.